Have you ever wondered what occurs on the inside of an atom? Aside from the commonly known subatomic particles, consisting of protons, neutrons, and electrons, there are many other particles contained within atoms. These include hadrons, leptons, and quarks. There are a few types of technologies which allow us to observe these particles. The most common form of studying them is with particle accelerators. They have been around since 1937 and have since made enormous breakthroughs in the realm of quantum physics. There are over 30,000 particle accelerators in the world currently operating. There are two types of accelerators. First one being circular accelerators, which accelerate hydrogen particles in circles, and linear accelerators, also known as linacs, which accelerate and collide particles in a straight line. However, not all particle accelerators have a beam-on-beam collision. However, most are built with this form of collision in mind. Many of the linear accelerators are used in hospitals and preservation labs and are used for fixed target removal, such as removal of cancer cells. They sound complicated, but in essence they are actually very simple. They work by using a high-powered electromagnet on the outside of a metal tube to accelerate a hydrogen proton to speeds close to the speed of light, depending on the amount of power you put in. Each beam contains roughly 100 billion protons and is the same diameter of a human hair. Once the particles have obtained their desired velocity, they collide in specially designed collision points, which aims to observe what happens during the collision and see if any new particles are produced. In collision zones are giant dipole magnets or quadruple magnets, which sit on each compass point, and that is used to steer the beam so that the two beams actually collide. Sounds simple enough. Now, the largest particle accelerator in the world is the Large Hadron Collider, which sits on the France-Switzerland border. It has a circumference of 27 kilometers. It is able to accelerate particles up to 99.99% the speed of light. Now, the speed of light is 300,000 kilometers per second. So just think about that for a second. In this case, it is able to replicate up to 1/1,000,000th of a second after the Big Bang. Now that is a significant breakthrough because as of yet, the Big Bang theory is, just that, a theory. What I aim to do is create my own particle collider. It's not, particle accelerator. It's not going to be using fancy magnets, but I just would like to cover the simplicities of accelerating particles. Well, the first iteration was unfortunately not a success. There is also no footage of this, considering it was done several months ago and I hadn't planned on filming it at that stage. The marbles that I'm planning on using actually proved to be very resilient in their strength and didn't shatter when they were collided. I even went as far as to drop them from a one-story building, which is about 5 meters off the ground. Only about half of them actually sustained chips and splits. Also, the timing of the collision often occurred inside one of the two tubes. Now, this does seem not bad, but it's actually supposed to occur in a particular area, which was basically a plastic perspex box as a shield, in case they did actually have enough velocity to shatter, which they didn't. This may have occurred for a few different reasons. One, the blowers that I was using may have been blowing at a different velocity even though they were set for the same velocity, or they may have had different power outputs. Another reason why the collisions may not have happened in the spot that I wanted them to is because of the tubes that I was using at the time. However, one section of tubing did have a hole cut into the side of it. This most likely would have reduced the amount of pressure that the air was actually reaching, and thus also how fast the ball could be pushed. This was repaired with masking tape and paper, but originally it was just masking tape, and the ball, as it made its way around the tube, would stick, or would partially stick to the inside of the masking tape. So we then put paper over the hole and then tied it up and sealed it with masking tape. I had hoped this would work, but I discovered that it didn't, as the collisions were still taking place somewhere where they weren't supposed to. I was only using singular marbles, but in this particular case I figured that the blowers, because they also have a blowback, so if they reach too much pressure, all of the air goes out the back of the pump, rather than actually pushing more pressure. It's a high velocity blower rather than a pressure blower. Is probably the reason as to why the design failed. Alright, so I changed up the design a bit and went away from the old blower design idea and instead relied on gravity to do the accelerating for me. So what I came up with is this, Jesus, reverse camera, this. An absolute abomination, if you ask me, but yeah, well. Basically, what occurs is you grab marbles from a marble box, whatever, and you simply put them in a tube, like such, hopefully at the same time, and then they are supposed to collide down in this section here. Sounds simple enough. However, when I was originally testing it, the collisions were not occurring where I wanted them to. So to fix this, I simply put multiple marbles in the same tube and staggered them. Which means, like, instead of doing all the marbles at once, you do one, 2, 3, and basically meant you had a beam rather than, or sort of a trickle rather than a full load. So if one was wrong, the ones after it would hopefully work. I hope this has given you an insight into the science behind particle accelerators. Obviously, this isn't an extremely accurate model, but I hope it gave you some idea of the general idea of colliding particles. Thanks for watching, and please subscribe.